So let's try to do some problems, more buffer problems, to find the maximum moles of acid or base. So this problem states you have 1.2 molarity of HF buffer of pH 3.3 in a 200 ml beaker. What is the maximum moles of acid you can add? Now let's do the first problem first. You notice the difference between this problem and the last video's problem? In the last video problem, I told you the concentration of the weak base and the weak acid and weak conjugate base. But here, I don't give you the concentration. So then how can you find the concentration of the buffer? And one of the ways you can do it is using a little algebra trick, and I have done it right here, where we plug in the numbers with what we have. So we're given the pH of 3.3, which I did here, and the pKa of 3.14, which I have given you here. And using a little simple algebra, we can find of how much base to acid we have. And once you do some couple of algebra, we have base equals 1.5488 acid. Okay? If I'm going too quickly with this step, please let me know in the comment section. I could explain more thoroughly. Now, can I plug in the numbers right here, this base? No, because another important concept is I have 1.2 molarity of this buffer. And so we got to plug in this number to over here. Remember in my previous video, I said whenever we have 1.2 of the buffer, all that means is I have certain number of acid and certain number of base that gives me 1.02. And so once we plug in the B from the previous this B that we found, we get A plus 1.5488A equals 1.2 molarity. And once again, we do more algebra and we get A equals 0.4708. And then we plug in that number to our original equation from A plus B equals 1.2 right here. And we get B equals 0.7292. Once again, if I've gone too quickly, please let me know in the comment section and I would explain a little bit more thoroughly. Now that we finally have the concentration of our acid and base, now we can use a limited reagent table. Now, quick question. The base, do I plug this in right here? Do I? No, because remember, limited reagent is always in moles. And so molarity equals mole over volume. And so the molarity was 0.7292 moles, which we don't have. And how much volume do we have? 0.2 liters. And so the number of moles that we have is, let me use my calculator, 0.22 times 0.7292. We have 0.160424. And how much acid do we have? We have 0.4708, right? Molarity, moles over 0.2 LL. And so the number of moles we have is 0.708 times 0.2, 0.09416. I'm going to write down moles just to emphasize one more time. And you notice how, remember, the first question that we're asking is, what is the maximum moles of acid? Acid. And so the acid is here, and therefore this acid has to react with its conjugate with the base first. Okay? Now, at the moment, do we know how much acid we have? We don't. So therefore, I'm just going to put X. Okay? Now, this is super important, okay? When the base and acid react, wouldn't you assume this base would become less basic, right? And therefore, when we have change is minus X, and then acid would always get reduced to minus X. And since we're adding acid to the solution, doesn't it make sense that this weak acid would increase? Therefore, our final would be 0.160424 minus X. This would be 0. And then this would be 0.09416 plus X. Okay? Now, and so the question is, what is the maximum moles of acid? Now, let's do a quick review of a mole of of buffer capacity. This was also in the previous video where we're just adding acid. Therefore, the ratio must be what? Log of 1/10. Pretty much the ratio has to be 0.1. And this is super important, guys, that the most acid I could add is 1/10. It cannot be 1/11. It cannot be 1/12. The maximum amount of acid I could add is 1/10. Therefore, we're going to have 0.1 equal to the product divided by the reactant. And all we have to do now is solve for x. And then we get 204, 584 plus 1x, 0.09416. That's a 6 minus x. And then 1.1x equals 0.079576. Therefore, x is 0.0723 moles of acid. Okay? That is the maximum number of acid that I could add to this buffer. Now, just to recap, there is a lot of math going on here, but if you've been following along with my previous videos, it's kind of similar concept where we're mixing a buffer with some kind of solution. And so we first have to know what is the initial concentration. And we get that from using a little algebra right here. And then from that, we do a limited reagent, which is in moles. And the last step is to use that with 0.1 ratio. And the reason why we use 0.1 is that because the maximum number of acid we could add is 10. Therefore, 1 divided by 10 equals 0.1. The next problem is actually the same problem, but now they're asking what is the maximum base I could add. Okay, so all the numbers are same. Therefore, from the previous problem, we realized this acid is 0.4708 and the base is 0.7292. And I hope by now you guys know, can I put this right away? Nope. We got to convert that to moles. So the moles from the previous problem was what? 0.09416. And then the moles of base was 0.160. 0.160. 160,424. And we don't know how much base we're adding, so I'm going to put x. And similarly, since we're adding a base, it has to react with a weak acid. And just like the previous problem, since we're adding a base, it has to be less acidic, right? So we're going to subtract the acid, subtract what we're adding. And since we're adding a base, this base needs to get more basic. And therefore, at final, it must be like this. Now, since we're adding base, this is super important. We got to look at the ratio. Since we're adding a base, the maximum ratio it must be is what? 10. It's 10/1. Therefore, it's 10. So all we do is make 10 equals product over reactant. It's 0.160424 plus x. And then reactant is 0.09416 minus x. And then we solve for x. Minus 10x. 0.160424 plus x. 11x equals, let me get my calculator. Point 781176. X equals 0.0710016 moles of base. And that is our answer. It may seem is a lot of math, but I want to conclude buffers. As you rewatch the videos, just have a clear picture in mind. The biggest picture is find the concentration, and then if they ask for maximum capacity, for base is 10:1 ratio, and then for acid is 1:10 ratio, which is 0.1.